Hello, this is Praveena. So I'll be dealing with data link control. So under data link control, I'm going to talk about Hdlc, which is nothing but high level data link control protocol, which is a bit oriented protocol used for communication over point to point and multi-point links. Hdlc implements the ARQ mechanism, that is automatic repeat request mechanism. So let us see how to configure and what are the modes present to do this configuration. So coming to this configuration and the transfer modes, so actually Hdlc provides two common transfer modes, that is normal response mode and asynchronous balance mode. In this normal response mode, the station configuration is unbalanced in the sense when we talk about the primary station and the secondary station, the primary station can only send the commands and the secondary station can only respond to the command. The primary station cannot respond and the secondary station cannot send the command. This is why we call it as unbalanced mode. So when we talk about multi-point network, you can see there is one primary station and two secondary station. So again here, the primary station can only send the command and the secondary stations can only respond to the commands. Secondary station cannot send any commands to the primary station, or the primary station cannot send the response to any of the secondary stations. So there is another mode which is called as asynchronous balanced mode. Here you can see there is nothing called as primary or secondary. The stations which is connected will behave as both sending the command as well as receiving the response. So the primary, if I take this as the primary station, it can send the command and get back the response from the other station if I talk about the secondary station. So in asynchronous balance mode, both will be sending the commands and getting the response. So we'll just see in the next topic what are these frames. Why are these frames used? Actually these frames will provide the flexibility so that the modes whatever we saw, that is NRM and your AB, M, will be using. So when we talk about this Hdlc frames, there are three frames: I frame, S frame and U frame. I frame is an information frame, S frame is a supervisory frame, U frame is unnumbered frame. And each type of this frame will serve as an envelope for the transmission of the different types of messages. Whenever I talk about I frame, it's used to transport this user data as well as control information. Whenever we talk about this S frame or the supervisory frame, it's only used to transport control information. Whereas your U frame or the unnumbered frame is mainly reserved for the system management. That is, information carried by this U frame is only meant for managing the link itself. So let us see the fields present in these frames. The common field, you can see the common field here, that is your flag, address, control, FCS and again a flag. So what is this flag field? The flag field of an Hdlc format is an 8-bit sequence with a bit pattern 0 followed by 6 ones followed by 0 again. This identifies the beginning and end of the frame and mainly serves for the synchronization pattern for the receiver. When we talk about this address field, the second field of this Hdlc frame. So that is nothing but which contains the address of the secondary station. If a primary station created the frame, it contains a to address. If a secondary station creates the frame, it contains a from address. An address field can be 1 byte or several bytes long depending on the needs of the network. The third field is this control field. So control field is 1 or 2 byte segment of the frame which is used mainly for error control and flow control. So error control and flow control will be handled by this particular field called as the control field. Next field is the information field, which contains the user data, and FCS field is the frame checksum sequence field to identify if there is any error in the particular message. So when we talk about the control field, this is this particular field. So you can see the I frame, S frame and U frame. So I frames are usually designed to carry user data from the network layer, and they also include flow control and error control information. So the subfields here, you can see it just defines what is that particular field or what are the functions of that particular field. The first bit here defines the type of the frame. So your 0 means I frame, 1 0 is S frame, 1 1 is U frame. And the next 3 bits here, N of S, it defines the sequence number of the frame. So when I have 3 bits which is starting from 0, that is 0 0 0 to 1 1 1, so 7. So I will have up to 8 particular sequence numbers. So the last 3 fields here, that is NR, it corresponds to the acknowledgement number, and here we use piggybacking to acknowledge. So the acknowledgement number will be specified here. And this PF field is a single bit field which is a dual purpose field. So if the bit is set to 1, it can, that is if a bit is set to 1, if it is P, that means pole, F means final. Pole is, P is 1 when the frame is sent from the primary station to the secondary station. F will be set to 1, that is final will be set to 1 when the frame is sent from the secondary station to the primary station. So now coming to this S frame. So we have 2 fields of code here. So the 2 fields of code is, so we have 4 bits, 2 fields, that is 0 0 0 1 1 0 and 1 1. So 4 particular values will be there. So the 4 particular values for this code are nothing but receive ready, receive not ready, reject and selective reject. So you can see if receive ready, receive ready, receive not ready, reject and select reject. So the fields here will tell you if it is 0 0, it is receive ready. If it is 1 0, it is receive not ready. If it is 0 1, it is reject. If it is 1 1, it is selective reject. And coming to this U frame, so here again you can see the code. So you have 2-bit code and 3-bit code. So the 2-bit prefix here will tell you before this particular thing. So the 2-bit prefix and 3-bit suffix together having 5 bits can create up to 32 different types of U frames. And the most common types are, you can see this particular thing, 2-bit prefix and 3-bit suffix, which is giving a 5-bit type for your U frame, where the command is SNRM. So this SNRM is nothing but set normal response mode. So if your U frame contains a code as 00001, that means the command will be sent as SNRM, which is set normal response mode. So like this, you can see the U frame control commands and the responses. So let us see an example here, how the connection is established and how the connection is released. So you can see a U frame can be used for both connection establishment as well as connection release. So in this case, a node A is asking for a connection with a set asynchronous balance mode. So node B set asynchronous balance mode. Node B gives a positive response with an unnumbered acknowledgement. After this, there are two exchanges. So after the exchange, after the data is transferred, you can release the connection. So U frame here is disconnect. So U frame, node A is sending disconnect to B, and B is responding with unnumbered acknowledgement. This is how connection is established and released. So in this example, you can see how piggybacking happens without error. So here you can see again node A is sending a high frame, so the data frame is 0. So it exchanges the information and node B piggybacks with an acknowledgement. Here this is an acknowledgement. So again you can see I frame, data frame 0, data frame 1, data frame 2. Again your S frame is sending a receive ready, that is S frame sends a value that is 0 0 where it is receive ready. So this is without an error. So what if you have an error? You can see here the I frame is sent with a frame as 0. So a node A is sending a I frame. So node B is sending a I frame to node A, and it is again sending a, this is while piggybacking, you can see node B is again sending a I frame with data frame as 1, and you can see this particular frame is lost. So when you get a frame with 2, it has been discarded. So here you can see node A is sending S frame, that is reject frame or negative acknowledgement to node B. So like this the piggybacking happens. Thank you.